Now I've added a switchboard here, you will also notice that an upstream cable and an upstream protected device have also been added into our system. ElectricalOM will automatically select the smallest size cable and the smallest size protected device from the database. I'm now going to enter the circuit edit menu for the switchboard that I added into the design. This can be done a number of ways. One way is to do a double left mouse click on the object we wish to enter. We can also select the tab from the top of the screen here, or we can press F2 with the object selected. Here in the circuit edit menu, the information is split into two distinct areas. Over here on the left hand side is the information about the specific board that we have selected and the calculation data from the preferences that have been selected for that board. Over here on the right hand side is where we can edit and change the preferences and settings of the particular circuit of which we have been designing. In this part of the video, we will be looking mainly at the left hand side here of our circuit edit menu. Here at the top we can see for the object that we have selected where it is being supplied from. Below that we can see the information or plan prefix for the particular object we have selected. The plan prefix and description can be changed manually by the designer to whichever description or prefix they prefer. Here we have an information icon. These information icons, you will note, will appear throughout the software in various locations and places. By selecting on the information icons, additional information or messages will pop up on the screen to identify, give key information of what the object the information icon is next to. To the right hand side of the information fields, we have two tick boxes which change the behaviour of the circuit we are designing. The first object is active. What this does is when an object is not active, the software will know that the object is no longer powered in the design. As such, it will not take into account any downstream loads or the load of the board for the purposes of the reports. The next item is the use conductor. When we added our switchboard, we noted that it added both a conductor supplying the switchboard and a protective device. In the circuit edit, if we select this to be off, we are no longer now identifying the key information around the cable supplying this board. You will also notice, because we have no cable, that the calculation data is no longer relevant for this particular board. On our schematic, we will see that the cable has also been removed from the schematic automatically. Switchboards are part of distribution circuits in ElectricalOM. Distribution circuits will generally follow the same topology of information here in the circuit edit. Here, for our distribution, we can identify how our load is being defined and calculated at this point in the system. By default, sub-circuits is selected. What this means is our design current will be based upon any defined loads or final circuits we add downstream to this particular board. Just as an example here, I'm going to quickly insert a pre-designed distribution board. How to do this will be featured in other videos. Now I've added sub-circuits downstream to this switchboard, we can see that our design current has been increased based upon the loads defined on the final circuits. As well as the change in design current, here on the right hand side we can see various information to do with the downstream load that has been added to this board. As I'd added a single phase board, we can see that the load has been placed upon the L1 or brown phase of the system. Here, diversity at the board can be applied manually where necessary. You will notice that the power factor and harmonic items are currently greyed out, as these are defined later on in final circuits defined under the sub-circuits. Our next item under the load is to predefine the load at the distribution circuit. By selecting this option, you will notice that here on the right hand side the options have now slightly changed. Any load that has been put here will automatically be balanced among the phases at this point on the system. We can identify and put in how many amps per phase is here. You will see that this number is duplicated in the design current below in this area. Also on the predefined load, the power factor and the harmonics are also now selectable, so the power factor and harmonics at this distribution circuit can be defined by the designer. You will notice that whenever we change the design current on one of the phases, this will equally be spread across the other phases. The same goes for our power factor and our harmonics. You will notice that whenever we add things like a power factor or harmonics, this will affect the calculations. As you can see, when I made various changes here, new errors and warnings have popped up immediately to identify any inconsistencies or incorrect practices in accordance with the requirements of the design. Our next option under our load will be to identify load density. How to do this will be featured in other videos. Finally, under this load section, we have our spare load. I'm going to reselect our sub-circuits here so we can see the sub-circuits that we already predefined earlier on. By identifying a spare load percentage, we are going to add that to the predefined design current on the system. Here I'm going to add 10%. You will see when I added the 10% that our kVA on our phase has also increased, as well as our design current at this point. Please note that where this does add a spare load in terms of the design current itself, it does not add a number of spare ways to the distribution circuit.